Okay, so we're back and we are going to do the rest of Unit 7.2 or Lesson 7.2. And I don't know why, but this PDF has been a little bit cuckoo. This is supposed to be focus, the lesson focus. So it says you'll be able to model periodic contexts that do not involve circular motion using trig functions. What are you talking about, Miss Johnson? So what it's talking about is before we were using the Ferris wheel and it was very easy for us to see the relationship between sine and cosine and that the height and the distance from the center, right? So here we're just not going in a circle. We're going to use a different context. The bigger deal is that you'll be able to solve trig equations. Okay, so you've done everything with trig, right? You've graphed it. You've used it to describe position of a writer or the shadow. You've done a lot of stuff with trig. So now we're finally going to be able to solve the equations of whenever you have sine in there. And you kind of already know how to do that. Some of you already know how to do it just because you've held on to the idea that you know your 30, 60, 90, you know your 45, 45, 90 stuff. You know those two triangles backwards and forwards. So when it's asking you for stuff, you're going to recognize that, like, oh, I do know some of this stuff. But you also know that because we've talked about, and we did this in the jump start, what happens when our variable is stuck in sine. What do we use to get it out, right? All right, continuing on. You'll be able to solve trig equations. The question you'll be able to answer is how can we write functions to represent other types of periodic behaviors, such as the relationship between the length of time in sunlight as a function of the day of the year, or the period of vibration of a string as a function of length of a string on a musical instrument, or even the height of water in a lake as a function of the time of day. So all of these things have periodic behavior or even trig kind of like behavior. So the idea of a period just means for a certain amount of time it goes and then it repeats itself again. And that's exactly what you see with any of these contexts that they gave you. All right, so today, to prepare for the science fair, your team is planning a field trip to the beach to conduct some experiments that will require setting up lab equipment on a portion of the beach that is sometimes underneath the tide waters and sometimes exposed to the hot sun. In order to know when to remove the equipment before it is washed away in the tide, you have found the water level on the beach is given by this equation: 20 sine pi over 6 t. So if you remember from our previous lessons, you should know that you should kind of be able to recognize what this graph would look like. That 20 is the amplitude, how high and how low it goes based on the center or the midline. And that pi over 6 is telling you how quote unquote fast it's going, how many radians per second is it, right? So in this equation, f of t represents how far the water line is above or below its average position. So its average position, so think about the word average when it like normally or like it sits, some of them are below and above. Okay. The distance is measured in feet, and t represents the elapsed time in hours since midnight. Okay. So t is the number of hours since midnight. What is the highest up the beach compared to its average position that the water line will be during the day? This is called high tide. What is the lowest the water line will be during the day? This is called low tide. So the highest and the lowest, what number is in charge of the highest and the lowest? And hopefully you said the amplitude number, which is 20. So it's either going to be plus 20 feet above the average water level or minus 20 feet below the average water level, right? So I'm going to put 20 feet above average water level and then 20 feet below. So this is, if you've ever heard someone say something like along the lines of plus or minus 20, this is why they say that, right? Because your amplitude is going to take you, however much above or below your average. All right. So suppose that you plan to set up the lab equipment on the average water line just as the water has moved below that line. Okay. How much time will you have to conduct experiments before the equipment will need to be removed because of the incoming tide? How much time will you have to do all your experiments if as soon as it goes below, like, and you're going at the average, right? How much time do you have before it goes? Now, who is in charge of time and how fast something moves? And maybe you say, oh, it's that pi over 6 number, but that doesn't make sense, Miss Johnson, because pi over 6, that's not a time. That's like how fast something is going. And you're right. So let me bring in Desmos for this just so you can kind of see what is happening. And so I'll leave those. I'm going to type in this equation and it's going to say 20 sine pi over 6 and then t, which is x in this case. Okay, and then so let's see. So I don't know if you can see, but like it it looks kind of like a funny, like very flat, right? So first of all, this thing is moving really slow. Pi over 6 per second is fairly slow, which makes sense because if you think about like the tide, you don't actually notice the tide pulling away or rising, right? So that makes sense. So just so that I can show you, so here it is at midnight, right? And then you get high tide here, right? This is high tide. And then you go here, right? At this point. And then it says, is it T is in hours? Okay. And then, oh wait, is this in radians or degrees? Did I switch this thing yet? No. Shoot, he's in degrees. That's why. Okay. There you go. That's a little bit better. I was explaining as if it wasn't. Sorry, I forgot that I had switched this to radians. Okay, so here it is in radians, and now you're laughing at me, Miss Johnson. I thought you said it's okay. Don't worry. So here it is at midnight, and there's your high tide at 20, and then it goes down. Boom! You put the equipment in, right? You set up your equipment, and then it's a low tide, low tide, and then the water starts creeping back up. So how much time do you have from here to here? Well, here it's at 6-0. Oh, that's at 6, Miss Johnson? Kind of. I'm going to explain it. Don't worry. And over here, it's at 12-0, which makes sense, right? Because it's high tide, low tide based on a 24-hour period, right? So yeah, so this is going to be how long do you have from here to here? And you're like, oh, that's 6 hours. Okay. Exactly. So this is 6 hours. Sorry, I was just calculating something. Okay, perfect. Okay, good. Okay, so the next thing that they're going to do is, let me move out my Desmos. It says, suppose you want to place lab equipment 10 feet below the average water line. Below the average water line, okay? So back to your graph, just so that we're on the same point. So suppose, oops, I should have read that better. Suppose you want to place the lab equipment 20 feet below the average water line to take advantage of the damp sand. What is the maximum amount of time you will have before you will need to move the equipment? How can you convince your team that your answer is correct? Okay, so here you are. So 10 feet below. So this is kind of where we are right here, where I can't get it exactly, but somewhere here. 10 feet below. Oh, there it goes, right? 10 feet below the average water line. And now they want to know, how much time do you have before you'll need to remove the equipment? So right here, it's 7, -10. And over here, I'm going to try to get this, but I don't know if it's going to be nice or not. It's not. It's not a pretty number, guys. Oh, maybe it is. Oh, it is a pretty number. I just saw it, but I can't. There it is. Do you see it? There it is. It's at 11. So from 7 to 11, that's 4 hours, right? Your team has 4 hours to figure that out. And how did you figure that out, Ms. Thompson? Well, I just looked at this -10. That's 10 feet below the average. And then I kind of calculated the time from here to here. Okay. Another way we can figure this out is if we actually use algebra for this. Okay. So I already know my answer is 4 hours. And so, but I'm going to use my equations to figure this out. I want to know, when is 20 sine pi over 6x equals to -10? I want to know when that is. Okay. And it should give me a couple of different answers. So when I start solving this, you're going to still kind of like sad map this, right? Like, do you see how I want to get rid of that 20 first? Because I want to peel off all these layers to get to x. So yeah, you're going to divide by 20 here. That's not new information, Miss Johnson. You're right, it's not. So then we get sine of pi over 6x equals to -1/2. Okay, now, I don't know about you, but some of you, because you know your triangles, you're like, oh, I know that 1/2 guy, right? And so I'm just going to remind you, for those of you who don't know, I am referencing your 30, 60, 90 triangle, because this is your 30. This is 1, 2, √3, or it's x2x, x √3. It doesn't matter. And if you look at this, who is sine here? Who has the sine? Sine of what angle gives me half? Sine of what angle gives me 1/2? This is what this is actually asking over here. But some of you are like, Miss Johnson, there's a negative. I'll talk about that in a second. I promise. Don't worry. Right. So sine of what angle gives me 1/2? And you're like, oh, it's 30 degrees, Miss Johnson. And you're right. So that angle in there is, I'm going to call it pi over 6, or 30 degrees. I would prefer you to be comfortable with pi over 6, but I'm always going to write the degrees until you guys are comfortable with it. Okay. That's my reference angle. I now need to go to my unit circle to figure out, where is sine -1/2? Where is sine negative for my 30 degrees? So here I'm going to draw my unit circle, and I'm looking for the times when sine is negative. I'm looking for the times when sine is negative. When is sine negative? So some of you are thinking, oh, Miss Johnson, I know this, because you've connected sine to y. So I can ask the same question, when is y negative? And you're like, oh, on the bottom 2 quadrants, Miss Johnson. Exactly. So I'm going to draw my 30, 60, 90 triangles in there. Looks like this. Looks like this. Those are supposed to be congruent triangles reflected across, but Miss Johnson, she has trouble drawing things congruent looking. I'll try one more time. Yeah, that's still not it. Let me try one more time. When I tried. Okay, that's not good, but that's gonna work for now. So this is pi over 6, right? So it's this angle. I'm going to make them blue. It's this angle and this angle. So this one, some of you are like, oh, that one's easy because this is pi or 6 pi over 6, right? Then this has to be 7 pi over 6. And this other one makes sense because this is 2 pi or 12 pi's over 6. And then you took one away. So this is 11 pi over 6. So whenever I'm doing these, I'm always thinking about adding one or taking one away. So one more time, this is a full pi right here to here. So that's 6 pi over 6. And then notice I have an extra slice of pi. That's where I got 7 pi over 6. This one over here, I had 2 whole pies. So can you imagine I had 2 whole pizzas and they each were sliced into 6 slices. So how many pieces do you have? You have 12. 12 pies over 6, right? And then someone took one and ate it. So how many do you have now? You're like 11 pi over 6, right? So what does that mean, Miss Johnson? That means that my 2 answers for this part here is 7 pi over 6 and 11 pi over 6. Wait, what? So sine of what, remember here, sine of what gives me half? I just found them 7 pi over 6 and 11 pi over 6. So what does that mean, Miss Johnson? You're going to take this inside stuff and you're going to go pi over 6x equals 2 and pi over 6x equals 2. And then you're going to put my 2 angles, 7 pi over 6 and 11 pi over 6. Now, some of you are thinking, Miss Johnson, why don't you just plug it into the calculator? All right, cool. Let's try that. There it is. So I'm going to go sine, because you guys are like, oh, just use sine inverse. Okay. So I'm going to go sine inverse, right, of negative 1/2. And you're like, oh, Miss Johnson, that's radians. Let's use degrees. That's fine. So you're like, oh, Miss Johnson, that's at negative 30 degrees that you had talked about earlier. Yes. What's the problem, though? The problem is my calculator. How many answers did it give me? Yes, it gave me 1 answer. And according to this, how many answers was I looking for from here? I can't get it right, of course. From here all the way to here. I'm trying to get it and I can't. There it is. I clearly have 2 answers, right? One here and one here. Why did my calculator only give me 1 answer? So here goes your limits to your calculator. Your limit of your calculator goes like this. Your calculator can only give you one thing at a time. Okay, it can't multitask. It can't give you more than 1 answer. But Ms. Johnson, you just showed me that I have 2 answers. Why can't Desmos do that? Because calculators are functions. For every question that you give it, it can only give you 1 answer. Does that make sense? So that's where you as the boss come in and you figure out the rest of it. Okay, so the rest of this goes like this. So Ms. Johnson, where'd you get this again? So this inside part of the angle is what I was solving for. That goes there. And then the 2 angles that I found were right here, 7 pi over 6 and 11 pi over 6. So now I'm just going to solve for those by getting rid of it. And so if I multiply both sides by, let's see, 6 over pi, I get rid of this and this. So I'm going to multiply by 6 over pi. Notice I get rid of the pi and the 6. So my answer is 7. So x equals to 7. And I have 2 answers. So again, I'm going to multiply by 6 over pi on this side as well. Multiply by 6 over pi. And I get 11. So my answers were 7 and 11, which is exactly what I got over on my graph. And I got 4 hours as my answer again. So I showed you two different ways. I showed you from the graph and I showed you algebraically. If you want, I can also plug it in as a table, and that's your other alternative way. Let me show you by table. Let's see. I'm going to make this equation. I'm going to write this equation as, where's my equation? Oh, there it is. 20 sine of pi over 6 x1. X1, if you remember, just pulls this value here. So I'm going to put the numbers in here like 1. Well, I already know that it's going to be some number. I'll go 3, 4, 5, 6. And remember, I'm looking for negative 10. 7, 8. And I got a 7 at negative 10, 8, 9, 10, and 11. So because I got these two negative 10 here's, that means it's going to take me 4 hours. I have 4 hours to do all that work. Okay. All right, moving on. It says, suppose you decide to place the lab equipment 15 feet above the average water line to give you even more time to do your work. What's the maximum amount of time you will have to carry out your experiment, and how can you convince your team is correct? So now I'm gonna say, look, you can do the same exact thing using this method here, algebraically. You could check your answer over here because now you know it's 15. You want to put it 15 units away. You can use your graph as well. 15 is let's see, somewhere here. So it should be somewhere here. So I just passed it, but it's, as you can see, it's probably going to be some weird decimal, right? So go ahead and solve this. My thing is I'm going to push you towards solving the equation algebraically. Okay. Go ahead and do that and then come back to me. Okay, now that you're back, I wanted to show you how to do this graphically and algebraically. The first thing I'm going to do is I'm going to graph the line y equals to 15, because that's basically what I want. And then now you can see my two solution points at 4.38 all the way to 13.62, right? So those are going to be my two answers. And then that tells you how long I have, which looks like it's like 9-ish hours. A little bit more than 9-ish hours. Okay, so there's my answer. I'm going to write that down just so I have it. So I got 4.38 and 13.62. And then I'm going to subtract those numbers, 13.62 minus 4.38. And so my answer is about 9.24 hours. Okay. Okay, so now I want to solve the equation just so that you guys are all comfortable with solving the equation. Actually, I'm not going to solve the equations. Should I solve the equations? I'll show you how to. I'm just going to set up the equations and then you can use, yeah, I'll show you how. All right, so it goes sine, I don't remember my equations. Sine, hold on, let me look up my equation real quick. Oh, 20 sine. So 20 sine of pi over 6 t is equal to 15. So again, I'm going to divide and I get sine of pi over 6t equals to 15 over 20 is 3/4. And you should be like, hey, Ms. Johnson, that's what we used earlier. We found this earlier when we did our jump start. And you're right, we did. So I'm going to show you using the calculator. But Ms. Johnson, you said that the calculator only gives me one answer. I know. I'm going to show you using the calculator so that therefore you can find the other answer knowing what you know. Okay. So here we go. I think I left it on here. Did I leave it on here? Yep, I did. Sine inverse of 3/4. So I'm going to take the sine inverse of 3/4. So I'll go sine inverse here. I'm going to squeeze them in here because I don't have a lot of room to write. So these two will cancel. I get pi over 6t is equal to, and then so I get the answer. Let's see. I think I'll do this in degrees. 48.59 degrees. Okay. So then this is where, so you're like, okay, but Miss Johnson, that's not the answer. I know, because I still have to work. And this is the weird part because I have pi over 6 as the answer. So maybe I should have didn't used radians. So I'm going to say 0.848. So I'm going to go with 0.848. 0.848. Because now I have radians with radians. Does that make sense? So then, so this answer here, 0.848, or if we were talking about radians, what was it? I forgot already. 48 degrees. I'm going to graph that. So 48 degrees is somewhere up here, right? Right. Where else is sine positive? You're going to hear me say this question over and over again. So where else is sine positive? And you're like, oh, well, if I ask you where else is sine positive, you're going to say, oh, Miss Johnson, that means where y is positive, right? And I say, yes. And you're like, oh, it's above the x-axis. So you're right. It's also here. Okay. So that's the other angle, right? So it's going to be 180 minus 48 is my other answer. It's going to be the other answer. But here, I'm going to be using radians. So just kind of keep that in mind for now. Okay. So let's see. So then I'm going to so what do I do here? Trying to figure out how I want to show you this. You know what? I'm going to convert pi over 6 into your into degrees because that's just easier for my brain to go with. Because right now I don't want you to get confused on this. So this is what it was. It 48 point something. What was it? 48.59 degrees. There you go. So I'm going to convert pi over 6 into degrees. So that's just 30t. So this is pi over 6 equals to 30 degrees. So I'm going to erase this pi over 6 and write 30, and then you'll understand why. Okay, so 30t equals 48.59, and 30t equals to, now remember, I need both of these angles. So how do I figure out this angle right here? How do I figure out this angle right here? Very good. Some of you are like, Miss Johnson, this is just 180 minus 48.59. So then I am going to do that on my calculator so I don't make mistakes. So that's 180 minus 48.59, and that's 131.41. So that's the other angle I'm going to use. So, Ms. Johnson, why did you have to write both angles again? So if you go back to this picture, right, there's two parts that are my answer. Here, right here, and right here. So I'm looking for both of those angles. I'm looking for both of those numbers. Sorry, not angles, but times. I'm looking for both of those times. So then when I divide by 30 here and divide by 30 here and divide by 30 here and divide by 30 here, what do I get? So 2 equals 2. So let's go. Where is it? 48.59 divided by 30 is 1.61. Uh-oh, what did I do? Hold on a second. Okay, So this very first, oops, I erased it. The very first answer I got, which was, oh man, I erased it. 48.50, oops, 48.59 divided by 30. So that's this point right here, right? That's that point right there. I don't want 1.62, right? That's not, I'm not going to set it before, well, on the way the tide is going up. I want to set it after. So I want to go here. So I'm going to skip 1.62 and cross it out as not the answer. And then I'm going to go to the next one, which is 131.14 and divided by 30. And I get 4.37, which is exactly what I got up here. So I got 4.37. And you're like, Ms. Johnson, but you need one more. Yes. So what I'm going to do is I'm going to take my 48.59 degrees and I'm going to go in a complete circle. This is going to sound weird, but notice that the tide is going to go and it's going to be a complete circle. And then I'm going to go again here, right? So I'm going to add a complete circle to 360 and see if I can get that other to be right. I can't. Okay, plus 360, and I get 13.62. Miss Johnson, how did you know to add a whole a whole circle to it? I did because, like, remember we have talked about like the cycles of things, and so the cycle of this one is going to go up high tide, low tide, midnight. So because we went through a whole cycle, then that means we can go through another cycle. So we're basically going from whatever 4.37 is as like 4 o'clock in the morning, right? All the way to the next day, passing midnight, or not passing midnight. I'm sorry. This is passing noon and then be here, right? So a whole cycle goes by. Okay. And then so I can get that one. So there's your two answers. I know this was confusing, but here's what I want you to be comfortable with. Number one, this question here is what you're going to constantly hear me say. Where else is sign positive? Because your calculator, remember, is only going to give you one answer. Okay. So keep asking yourself, where else is it positive? Okay. So the next question, it says, you may have answered the previous problem using a graph of the tide function. Is there a different way you could use algebra? So we actually did that. We did algebra for problem 3 we did up here. We also did algebra for problem 4. So we're going to skip number 5. It says, suppose your team decides you only need 2 hours to conduct this experiment. What is the lowest point on the beach where you can place the lab equipment? Okay, so now they're asking, you only need 2 hours. We only need 2 hours. So like say from here to here, I don't know where that's going. There it goes. From here is 8 to here is 10. That's that's the lowest, right? Do you see how that works? That's the lowest that it can go. So, but Miss Johnson, how do you do this? Wait, hold on a second. So how do you do this? So if I need 2 hours, they basically need an hour on each side of the lowest tide. An hour to the left when it or an hour before it reaches lowest tide, and an hour after. Does that make sense? An hour before and an hour after. So to determine the lowest point, you're just basically going to look at that lowest tide, which is at -20. And then when is that? Right? So when is that? So according to this, it's at 9 hours after. So that's 9 o'clock in the morning, I believe. Right? So you would only need to figure out the the hour before that, which would be 8 o'clock, and 9 o'clock. That would be on the way in, and then from 9 o'clock to 10 o'clock. So there's your 2 hour window. You could also do this 2 hour window over here, right? And this would be, I think this would be 8 p.m. to 10 p.m. If I scooch this over a little, this would be from 8 p.m. to 10 p.m. Okay, so let's see what the question is asking. Oh, where can you place the equipment? So the where can you place the equipment, that's going to be your why. So you're going to be able to place your equipment 17 feet. Is it feet? 17 feet below the average level. 17 feet below the average level. And so the way you would calculate this is, because we knew the lowest point was going to be 9 o'clock, right? We knew that. So then we would just plug in pi. So we get 20 sine pi over 6. And we'd plug in 8 because that's the hour before. And so when we plug that in, that's going to give us our 17.32. So 20 sine pi over 6 times 8, and that gave you your 70. Don't worry about this negative. It just means below the average. It means below the average water line. Does that make sense? And so that was negative 17.32 feet. And so hopefully this is making sense of you reading the graph and you pulling information off the graph. Okay. So the last thing we're going to do is we're going to go over our takeaways, and there's quite a bit of takeaways. So I'm going to try to make sure that it makes sense. So solving trig equations requires, just like you knew before, isolating the variable. But before you isolate the variable, you had to isolate the trig function, right? And then you would, so here's where we split, right? You either apply the trig function, like the trig inverse, or by using like your 30, 60, 90, 45, 45, 90. So then use inverse to solve for angle, right? Or you can use your special right triangles, which is what I really like. So the thing that you'll have to do is not forget asking that question. And that question kept coming up. Where else is sine or cosine positive or negative, right? That question kept coming up. So then it says trigonometric functions can be used to model periodic behavior such as the tides, the average length of sunlight, temperature. It's all of those things. Okay, so it doesn't have to be circular in nature. It says answer problems that involve using inverse trig functions to define specific instances in time in such context may involve, so finding an angle of rotation, like understanding what those values mean. So these are all things that are what you're going to be doing. So now you'll be able to understand how to do this exit ticket. I'm going to try to scroll and show you, take a sneak peek. It says solve the following trig function to find a solution of the variable t. So think about this and think about unpeeling all of those layers, basically SAD mapping, right? And just know that the sign, like where's sine found, that's all the way in parentheses. Okay, so if you can do this, you would be good. Now, when it says on the interval from 6 to 8, they just want the t that's somewhere between 6 and 8. Because if you know about sine and his nature, there's all of these answers. The number of answers is literally infinite. So when we restrict it from 6 to 8. I only want you to give me an answer between 6 and 8. Does that make sense? And so now if you look at our homework, our set, right? You should be able to answer all these questions. Find the amplitude, right? Are you going to be able to find all of these things? So thank you for listening. I hope you have a great day. Make sure you come with questions. Have a great, great day. And remember, if you're feeling a little uncomfortable in this, that's okay. You're kind of supposed to. Have a great day. Bye.